Okay, the first code is the get extreme code. We have a function declared which gets the extremes. So in the main function, the first line is declaration of min max variables and an array variable in which some random values are given. So here we can see we have a min variable which will store the minimum value in that array, the max variable which will store the maximum value in the array, the array which has the values, and the n which will get the size of the array. So in the next step, we will run the array, get the values, then we get the size, and we get the size set to be 10. Then our next line will be get extreme. We will call the get extreme function. So the get extreme function will first set the first variable in the array. The first variable in the array is set to max. So the array pointer is here, the max pointer sets to 2, and the min pointer is also set to 2. So we run the minimum line. So minimum is set to array 0. So we'll get the first element which is 0.2941. So we get 0.4921. Then we run the max line and we also get the max set to be the first element. Then we run the loop. This loop through the array. This loop run from element number 2, index 1, which is the element number 2, as element number 1, which has index 0, is already set to min and max. This loop will run to the size of the array. The first condition is to check the minimum value. If the array's element is smaller than minimum, we will update the minimum array. And if the array element is bigger than the max element, then we set the max element to the element which is compared right now. So you can see the minimum remained the same, the max updated, as 0.2941 is smaller than 0.8173. In the next iteration, which is the second iteration, we can see the minimum stayed the same and the minimum just updated. Okay, the minimum updated as the third element is 0.02528, which is smaller than 0.2941. And the maximum will remain the same as 0.0528 is smaller than 0.8173. And for the next iteration, nothing changes. For the next iteration, again, nothing changes. For the next iteration, we see the float changes, the max float changes. So we have the element number 5, which is 0.9325, which was greater than the previous stored max element, which was 0.8173. Next iteration, nothing happens. Next iteration, again nothing happens. Again nothing happens. And again nothing happens. So we have ended the loop. This will be the last iteration. And in the next step, we are outside the loop. We are outside the loop, we are outside the function. And now we are printing the values. Now we are not using any of these array. We are just printing the minimum variable and the maximum variable. Then we pause the system and return 0. Okay, the next code is the standard deviation code. In this code, we used another library, the CMath library, for the square root function. So we have a function, standard deviation function, and that's the main function. So initially, in the first step, we declare an array, a double data typed array, which have some values, which have 9 values, 9 elements. Then we calculate the size of the array, which comes out to 10. Okay, we don't have 9 elements, we have 9 indexes, we have 10 elements, and the size of the array is 10. So the next line of code prints the standard deviation by calling the function standard deviation by the parameter x and n. X is the array and n is the size of the array. So we jump to the array. So we jump to the standard deviation code function, which returns a double code, which gets the double array by value and integer n by. So the formula for standard deviation is square root summation of each element subtracted from the mean squared divided by 1 less the size of the data. So in the first step, we will set the double, the sum. We create another variable called sum, which we will set equal to 0. Okay, the double, the sum is set to 0. Then we run a loop which is starting from the first element to the size of the array, and this will calculate the sum of each element, which will be equal to, like, which will add every element. So we are at the fifth element, we are at the sixth element, 7, 8, and the last element, the 10th element. We get the sum equal to 60, and that integer I disappears. So now we will calculate the mean, which will be equal to 60 divided by 10, as sum is divided by n, sum is 60 and n is 10, which is 6. Then we jump to the next, the mean, then we jump to the next. From this we get double square sum equal to the, so now we get the squared sums from the mean difference, which is set to 0. Now we are going to run the for loop, same for loop, but just now for squared sums. So in the first iteration, we had 1.5 minus 6, so we get 20.25. Okay, that's squared. So 6 minus 1.25. So let's calculate that. 1.5 minus 6 and then squaring it. So it's 20.25. So that's happening here. Then the second element, then third, then fourth, fifth, sixth, seventh, eighth, ninth, and the 10th element. So at the 10th element, now I will again disappear. So we have the squared sum is 28.5. So now are we going to return the standard deviation? We have the difference. We have the sum squared difference and their sum. Now we are just going to take divide it by n minus 1, which is the size of the array, and take the square root of it. So we are returning the value, and it's just going to be printed, and we get the system false. Okay, this is the matrix multiplication code in which we have four functions, including the main function. We have a get value function which will get the values for both matrices, matrix A and matrix B. We have the compute function which will compute the multiplication of function of both the matrices. We have the print function which will print the result array. So let's run this code. So initially we have three arrays. We have array A 3 by 3, array B 3 by 3, and result 3 by 3, which have all the values set to 0 initially. So we can see we have unknown values or garbage values in this. We have unknown or garbage values in array B. We have all elements set to 0 in result array. So the first function that we will call will be the get array function. So we call the get array function which will get the inputs. First we will take input for the first matrix, then we take input for the second matrix. So first we need to access the row, then we need to access the column in that row. So as it's a 3 by 3 matrix, we have 3 rows and 3 columns. So we have a loop that will run 3 times and another loop that will also run 3 times within that loop. So we have a loop that will run 9 times in a loop and a loop that will only run 3 times. So for the first matrix, it goes into the first row. Now it goes into the first column of that first row. So we are at the index 0, 0. So here we can see we have I set to 0 and j set to 0. So we are accessing array 1 this element and array B is this element. We are not setting array B right now, but we are setting array 1A right now. So at the next point, okay, we are getting the input. We take the input, which is the first input is 1, it is entered. So now we have, now in the next step, you can see J updated. I didn't update, so we set I to the row 1. First we get the element for row 1, all the columns are filled, then we go to row 2, then we go to row 3. So we are at I equal to 0 and j equal to 1, so it's the second element in the first row. So it's the second element in the first array in the 2D array. So we get int equal to 2. So in the same way, we will take all the inputs for, so now we are in the row 2, the second element. You can see we have I set to 1 and j set to 2, so we are getting the third element. And here we get the third element. So in the same way, we get all the element. We have get all the elements. For j, we got out of the first loop. Now we are at the second loop, at the outer loop, the row loop, and now we will be out of the other loop too. But as soon as we get out of the loop, we get into the another loop for the matrix B. So I set to 0, now j set to 0, and then we will repeat everything we did for row A, for array A, for array B. So we get the inputs one by one. So here we go, we got all the inputs. So j goes and I goes. So this function is complete. Next we go to the second line, so which is the compute AX in the main function, which is compute AXA. We give it the array A and we give it array B and the result array. So here we can see array A is by definition by value, is passed by value, array B is passed by value, but array 3, the result array, is sent by, or the parameter is set by reference. So we are going to manipulate this array, and we are not going to manipulate array B and array A. We are just going to use them to manipulate the result array. So here we are going to use 3 loops. First loop for the row loop, second for the column loop, and third for the multiplication loop. As in matrix multiplication, we have, if we have an element A, B, and C in the first matrix, and just say we have random elements in here, and we have 1, 2, 3 in the column of the second matrix, and we have other things in the other column. So in matrix multiplication, we multiply rows into columns. So we will multiply in the first matrix, we will take the element A and multiply it by 1. Then we take the element B multiplied by B. Then we take the element C and multiply it with the 3. So for the first element of the result array, we will get this. So the first element of result is A multiplied by 1 plus B multiplied by 2 plus C multiplied by 3. Then we get the second element, third element, Then we get the second column, then we get the third column. So this is how matrix multiplication is working. So we get the row, we get the column, then we multiply the, then we take the first element, so the first column, first row element, and multiply the first column, first element, first column, first element. Mhm. Okay, that's shown the code now. So now we are in the loop. So we are pointing at the first element of array A, the first element of array B, and the first element of array B. Then we get J. J value is also set to 0, and we also get K, and K values is also set to 0. So we are accessing all the first elements. So in the first element, we just multiplied 1 by 11, so we get 11. In the next loop, we'll get K equal to 1. So K equal to 1 gives us array A first element, K is the second element, so we are getting the second element, we are getting 2. Okay, we are getting 2, and we are getting K 2. So in the array B, we are accessing second element, so we are getting the second array, but the first element J is set to 1, so we are getting this. So in row 1 we are getting, so in array 1 we are getting this, and in array B we are getting this. So we can see we just add 39 to it. So 11 plus 20, 11 plus 28 is 39. So in the next row we will get K equal to 2. So we are accessing this 3 in array A and this 17 in array B, and adding it to the already present result 39. So this becomes 90. So now we have completed the innermost multiplication loop. We go back to the column loop. So now the j is updated. J will be updated to 1. Now j is 1. Now we are going to this array, this element, the second element in the first array. So it's 12, as 12 1 12 1 times is 12. Then this will go on to for every element. So in this way we will multiply every element, and then we will go to the print array, which will get the row, get the column, and print the result of the array. Okay, let's move on to the next code. So in this code, we are taking a string and calculating the number of space character, the tab character, the number of characters, all the characters, and the number of lines. So initially, we create four variables: the space, tab, character C, and characters. This is the character variable, and this is the lines variable. All are set to 0. So all are set to 0. Then we call the function input and call it by the space, the tab, the character, and lines variable. We call them by reference. We call all the variable by reference. Then we create another variable called string line, which is empty string for the input. Then we tell the user to input the text and press the Control Z in the next line of your text to generate the end of file character to stop the input process. We use cout and tell the user to enter text now. Here we use getLine, which will get lines with the space character. Otherwise, the space character will cause an input, and scene will take it multiple input in that case, and our code will not work. So we are getting the line, which is by the cin function. So we are getting the input, and storing it in the string variable line. And as it's in the while condition, this will stay true until we are pressing the keyboard or it's still getting the key presses. It will get false when it gets a specialized character. We set the getLine function to pause on a certain character, or we just push the end of file character, which is made by using control and Z in a terminal or a file. So this loop will run until we generate an end of file character. The next loop is for the for loop. This is a for loop like the for loop in Python, like the in loop. So this checks for the character C in line. So for character C in line. This will take every character in the line as we are pushing the button. So as we push a button on our keyboard, it gets that character and run this loop. So in this loop, first we check if C is a space. If it is a space, then we increment it. As you can see, it was not a space in our input. The first thing is the process. So the T is not a space character. So we go to the next. So tab, it's not a tab character, but it was a character. So we incremented character by 1. So we will run this loop again and again. So we get another character. We get another character. So this time we got space because after the we have a space. So we get space incremented by 1. It was not a tab, so a tab will be 0. And as space is a character, so character is also incremented. So this will run. So we have a tab space somewhere. So after, I think the, yeah, straight after the we have a tab space over here. So we run this code to somewhere. So as you can see, characters are increasing, tabs are increasing, space are increasing. Lines are not increasing as I didn't insert any line in this code. In the example code, I will add a line. So this code will run until we have an end of line character. So now as this input is called, so these are called by reference, so they are updated this globally in the namespace standard. So then we can print that by calling the variables as they are updated globally. So let's run this code in Visual Studio. So this is the code over here. Okay. To input text, press Ctrl Z to generate end of line, end of file character in the next line and hit return. So we will enter a random text. So here I'm going to add a tab character. Here I'm going to add a space and a new line. So I added a new line over here. Now let's create a list. Add a tab 1 dot tab 2 dot and tab 2 dot root. Now I'm going to stop this by pressing Ctrl and Z. So this is the end of file character and hit enter. So here we can see this is we have 10 spaces. So let's calculate it. 1, 2, 3, 4, 5, 6. I think I have one here. 7. I don't know where are the other 10. So okay, let's see. Okay, we have one here. 7, 8, 9, 10. Okay, okay. 7 over here and 3 over here. So we have 10. We have tab character, 4 tab character. 1 tab character is here and 3 over here. We have 63 character overall, okay. And we have 4 lines, 1, 2, 3, 4. And the end of file character line is not included in the code. Okay, this is the last code, the mean median mode code. So in this we are using another library which is algorithm library for the sort function for the median. So we have three functions. We have mean, median, mode. These are the three functions and the main function. So firstly we create a array, double array which store I think 10 values or more. I think they are more values. I think 25 I guess. So we have random values in it. So we initialized it. Okay. Now we calculate the size of the array. So the size of array is 25. Okay, here how the values are all. So first we print the mean and we get the mean by calling the function mean by pushing the array and the size of the array. So we go to the mean. So it is returning a double. So first we set sum equal to 0. We run a loop where I is equal to 0. The first element, it runs till the last element and I is incrementing by 1, and we just get the sum of the all the element of the array. So n set to 25, the sum is 0, the I is 0, so we are at the first element of the array. Okay, the sum is now equal to 7.2, the first element. Now we are pointing at the second element, 15.5, added to it 22.7. We will do this for all the elements, so we will do this till I is equal to 24. So we get sum of all the elements, which is 325.6, and the loop is ended. And we just return the sum divided by the size of the array, which is the mean. So the mean will be 325.6 divided by 25, and it will be printed. So the mean is 13.024. The next function we will call is the median, passing the array and the n by value. Okay. Firstly, we will sort the array. For median, we need to sort the array as median is the middlemost value in a set or a data set or an array or anything. I don't know. In median, we need to sort the array as median is the middlemost value in a data set. So firstly, we will sort the array. What's happening here? So the array we call the first array, the pointer is to set to the first element of the array. And array plus n, which will give us the last element, last element, 24, and the data is next to it. So we will start from here and work till here. So the sort array sort the elements till the address before it. So we will sort the array, and you can see the array is sorted. Now the first element is 3.1, 4.4, and the last element is 29.1. So the array is sorted. Next thing that comes is the data set an even data set or an odd data set? If the data is even, we have two middle values. So let's see over here. If we have an even set data set, let's say we have 12. So we have the middle values set to be 6 and I guess 7. Yes. But if we have the 13 values, then the value number 7 is middlemost, as we have 6 values before it and 6 values after it. And for this we have, I think, 5 values after it and 5 values before it. So for even we have the element number 6, the element number 7, and divide that by 2 in a data set of 12. And in an odd number, we just get the 7th element. In our case, we have 25 elements, so we will not run the 20 even loop, we will run the odd loop. But for the even loop, what we are going to do, we are going to access the middlemost value and the value before it, and sum the answer and divide it by 2. So it's going to check the condition, which is not true, so it's going to jump to the else. So at the else, we are going to find the median, which is array n divided by 2. So we have median set to 0 right now. So n divided by 2, 25 divided by 2. As this is integer division, not a float division, so we will get 12. And from 0 to 12, the 12th element is actually the 13th element in real life if we calculate 1 as 0 as a 1. So in a data set of 25, 13 is the middlemost, as it has 12 elements to its left and 12 elements to its right and left. So now we are just going to access, so the 12th element is 12. So I think we are going to access 12. Yeah, median is 12. Then we are going to return the median. And we are going to print the median. So the median is 12. Now we go to the mode. So the mode will be the most frequent value in the data set. So the data set is sorted. Still, I don't think so the data set will be sorted. Oh, that is, the data set will stay sorted after the sort function happening in the median function. So we set the mode equal to 0. Then we set the frequency equal to 0. So we have now two variables. Mode is set to 0, frequency is set to 0. Then we run the loop with the integer I and the count 0. So we have how many loops? The count is set to 0 and we have another loop j. So this loop will iterate over the array and this loop will iterate over the checking. So this will check the first element with all of the other 23 or 24 elements, then run back to I. This will go to the second element, then it will check all the other elements. The next element, not the element before, as it's already been checked. So see, we are going to, if array I is equal to array j. So if the first element is equal to the first element, so first element is equal to the first element, so the frequency will be 1. Count will be added, so frequency will be 1. And this loop will run, let this loop run 25 times. So we have count still 1, and this loop will run, okay. Okay, this was the last element. So count is equal to 1. Now we are going to check if count is greater than frequency. If count is greater than frequency, then frequency is updated by the count. So the highest frequency will be the count. 1 is the highest frequency right now. And mode will be the array element. So right now, the first element is the highest occurring element. So frequency will be set equal to 1 and mode will be set equal to the first element. This will happen with all of the element, and we can see I think so 15.5 is the most occurring element. Here this code will not execute, I think so fully. Okay, let's see something. Okay, at a moment like we are, I don't know where we are. Okay, we are at the frequency is 1, I is 1. We are at the second element, and second element is repeating twice. So we just updated the we will update the mode by 4.4 in like 4 iteration after, and the count will be updated to 2 also. So the new mode will be 4.4. For 5.8, it's occurring less time than 5.4, so no update will occur. Similarly for 6.3, 7.2 is same, so 4.4 will stay the mode. 8.9, nothing happened. 9.7, nothing happened. 10, no, no. 12, no, no. For 15, this will run like 1, 2, 3, 4, 5, 6. This is occurring 6 times. So the count will be updated to 6 and I will be set to like I think so 14. It will go to 15, 16, 17, 18, 19 and till 19 it's same. So 15, so 14 will be the array that will go into the mod, and as 21, 22, 23 and 24 are not repeating, so the the element at the index 14 will be the mode. So here I cannot show you, so you run this and 15.5 is the mode. Similarly, let's just delete a single element here to make it even numbered data set. So we have a different mode, median. We will have a different median right now. I hope so. Okay, the last time we have median equal to 10. This time we have median 11.8. So